Right here, I got a quick video. I'm going to make it as quick as possible on scientific notation. This is just a general skill you should be able to have. You'll probably learn it in math class, but just something you need to be able to do and understand when you're looking at some numbers and possibly how to get in and out of scientific notation. It's not something we're going to be spending a ton of time on this year, but it is something you should be able to do. So real quick, if we're looking at say the width of the universe, there's going to be some obnoxiously large number. It's like 210 hextillion miles wide. That's the estimation on the width of the universe. Really, really big number. Not something that you're going to communicate easily. It's like the number 21 followed by 22 zeros. It's just huge. Not something you're going to want to write out a lot. So what you'll often end up doing is writing this in scientific notation. So when we write things in scientific notation, we write this like this is our format, is that the number is expressed as a times 10 to the nth, where a is some number between 1 and 10. It'll never be a number, it'll never be 10, it'll never be larger than 10, it's always going to be a single digit and then possibly decimal point and other numbers afterwards. So it could be like, in this case of the universe, it could be like 2.1. It would never be 21, it would never be 0.21, it would always be a whole number, then decimal point, and then any additional numbers following. So like 2.1 would be an example. And then n is some integer, some whole number that we're going to use to multiply it in the converting in and out of scientific notation. So if we look at this, I go and I place my decimal point between, all the way over here to the left-hand side, between the 2 and the 1. It goes right in this place here. So that's where we're going to move the decimal point. As of right now, the decimal point's all the way over here on the right-hand side after this last 0. So we need to move this all the way over here to get a number between 1 and 10. That would be 2.1. So that's where our decimal point needs to go. This means we need to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 places. That's how many places we're going to need to move the decimal point. So how many places are we moving? We moved to 23 points, so 23 positions. So that's the number that goes after the 10. That's the integer that goes in that n position. So our scientific notation for the number 210 hextillion miles, we would say it's 2.1 times 10 to the 23 miles, or 10 to the 23rd miles. That would be how we would write that out. And notice it takes up a lot less space, and as numbers get bigger and bigger and bigger and bigger and bigger, the amount of space you save becomes greater and greater. Now sometimes you'll have numbers that are really, really tiny, way less than 1. And in this case, we do the same thing. We move the decimal point to the place where it's going to be after a single whole number. So or a single integer, like the 9. So in this case, move the 0 from here, or the decimal point from here all the way over just after the 9. So my number in the A position is going to be 9.02. And I move my decimal 8 spots to the right in order to do that. And since I move my decimal to the right, and I'm going to have a number, my actual value number is less than 1. My integer after the 10 is going to be, my exponent is going to be a negative number. So I take my 9.02 times 10 to the negative 8th, and this tells me that I moved my decimal to the right-hand side. So 9.02 times 10 to the negative 8th is how we would write that number in scientific notation. So if you were to take this number here, 28,750.9, we moved the decimal over here between the 2.8, and we moved it 1, 2, 3, 4. So it's going to be moved 4 spots and moved to the left, so it's a positive number. So it's 2.87509 times 10 to the 4th would be the right way that we would convert that. So it's really not a horribly difficult concept. It's just something that we need to be able to do in order to speak and communicate scientifically, because you will see some numbers are going to be in scientific notation, and you will at some point in your life have to convert things, whether it's in high school classes or possibly even this year. So we can do the reverse as well. We can take a number that's in scientific notation and take it out of scientific notation, so that's in a decimal format. And we just look at our number here. We have to look at the exponent and look at if that's a positive or a negative. If it's a positive, it means that our number after we take it out is going to be greater than 1. If it's a negative exponent, then it means that we're going to have a final number out of scientific notation in standard form that is less than 1. In this case, it's a positive number, so it means I'm going to end up with something greater than 1. And number 4 tells me I need to move my decimal point 4 spots. So 1, 2, 3, 4. I'm going to have these empty spaces over here. I need to backfill those with zeros. So when I take this out, I move to my decimal 1, 2, 3, 4. It's now here. Bang, there's my number. So 1.36 times 10 to the 4th is the equivalent of 13,600. Those two numbers mean the exact same thing. So you can try, if you were to try a couple on your own, just make sure it works for you. 1.8 times 10 to the negative 4th. The negative number tells me that my final number is going to be less than 1. And I'm going to move my decimal to the right 4 spots. I'm sorry, I'm going to move my decimal to the left 4 spots. So when you do that, bang, you're set, ready to go. And you can do the same thing with 4.58 times 10 to the 6th. Because it's a positive exponent, it means that my final number is going to be greater than 1, and I'm going to move my decimal to the right as I move out of scientific notation. So really not a horribly complicated skill, but it is something you need to be able to do, and this gives you the opportunity to come back and refer to this video if needed. Hopefully that helps. If you have any questions, let me know.